This is Captain Chaudhari in my series of videos on marine astronomical navigation. Today I am going to talk about the eclipses, the lunar eclipse and the solar eclipse. How the eclipses occur. What is the reason for that? Sometimes they ask why on every full moon there is no lunar eclipse and why on every new moon there is no solar eclipse. That means we do not have eclipses occurring on every full moon and new moon. There are limited number of eclipses which can happen in a certain year. Right. So first let's talk about the lunar eclipse. The principle is light travels in a straight line, and if that light is interfered or obscured, you'll have eclipses. So lunar eclipse will happen only on opposition. Opposition means elongation of 180 degrees. That means from Earth we find the moon and sun on opposite side. That is the opposition. So if we draw the diagram, and let's say I can make the axis of rotation like this, so equinoctial like this, and if the ecliptic is like this, where I must always find the sun, and let us say sun is over here. Now if the moon is over here, we will say this condition is a condition which looks like opposition. That means elongation is 180 degrees, or the moon and sun are on opposite side of the earth, right? But the precise conditions to be satisfied could also be like number one, the SHAs differ by 180 degrees. The declinations declination is the angle measured with respect to equinoctial, right? So declinations are of same magnitude. But apart from these two conditions, as I told you before, every full moon or new moon is not eclipse. We must have one more condition, that is the third condition, that moon should not be very far from ecliptic. And the contact point of the moon's orbit with ecliptic is nodal point. So we can say that moon should not be very far from the ecliptic point. So suppose this is ecliptic, and suppose this is the moon's orbit, right? So that the three bodies are more or less in line, we can't afford that the moon is very far from the nodal point. Moon should be reasonably close to the nodal point. So that is the third condition, that moon should be close to the nodal points. Now let us try and understand the solar eclipse. On the similar lines, let us talk now about the solar eclipse. Right? So let us say this is the earth. Don't go by proportion, because I just want to emphasize on certain points, like I have made the earth big. This is the plane of equinoctial and this is the plane of ecliptic. If the sun is here and we want solar eclipse to happen, the moon also should be on the same line. So what appears here is the SHAs are same, and the declination, that is this angle, declination same, name and magnitude. But apart from this, as we know that the moon's orbit is not in plane of ecliptic, moon's orbital plane is inclined by about 5¼ degrees to the ecliptic. The third condition would be the moon should be close to nodal points. If the moon is far off from the nodal points, what will happen is moon will be away from the ecliptic plane, and if the moon is away from the ecliptic plane, what happens is they don't come in line or nearly in one. So as I told you before, that moon in every month the moon crosses the ecliptic on two occasions at 2 points, that is ascending node and descending node. When the moon is at ascending or descending node, the moon is precisely on the ecliptic. But what we want is, when it is a situation that solar eclipse should occur, that means moon and sun, that means the elongation of moon is 0. At that point we want the moon to be not very far off from the ecliptic, and that will happen if the moon is not very far off from the nodal points. So let us understand in slight higher details, like what is the effect of perigee, apogee, and what is the effect of this penumbra, umbra, etc. So let's first understand what is penumbra and umbra. Penumbra and umbra are the shadows which are cast. For example, if we talk about sun being here, moon being here, and the earth being here, there is a shadow that is given out, by the moon in between. So this central conical portion, where the lights are totally obscured by the moon, that's called umbra, and the outer can-shaped structure, where the lights are not totally obscured, only partially obscured, and partially the light is visible there. So that is called penumbra. Let us look at other situation. This is the sun. Earth is obstructing the sun's light from reaching the moon. A moon could be in this region, moon could be in this region, moon could be in this region. So we say that over here the light is totally obscured and moon is in umbra. This central conical region is called umbra, and the can-shaped structure outside the umbra is called penumbra. So here the moon is in penumbra, and here the moon is in umbra. So accordingly we have three types of lunar eclipses. One is penumbral eclipse of moon, and other one is partial eclipse of moon, and the third one is total eclipse of moon. Now this penumbral, out of total number of eclipses which happen because of the moon, or the lunar eclipses, 1/3 of the lunar eclipses are penumbral type. Now this penumbral type lunar eclipses are difficult to distinguish from here. Even if you use the telescope, the powerful telescope, it is difficult to find out. So other than penumbral eclipses of the moon, there are two more types of eclipses of moon. One is partial eclipse of moon, and other one is total eclipse of moon. Partial eclipse of moon means part of the moon is in umbral shadow, right? And total eclipse means moon totally is in umbral shadow. As I said, penumbral eclipses are 1/3 of the total number of eclipses which occur. And similarly, partial eclipse as well as total eclipse are again 1/3 of the total number of eclipses. Now, in case of moon's orbit around the earth, if I exaggerate the perigee and apogee, here the moon is in perigee and here the moon is in apogee, right? So viewing from the earth, moon would appear bigger than the sun's disk, solar disk, and when we look at the moon in apogee, the disk of moon will appear smaller than the sun. Now, in case of sun, we can have three types of eclipses. Suppose we say sun is on this side and sun casts a shadow. The solar eclipse, when it is seen in the penumbral shadow, this is partial eclipse of sun, right? So the sun's light are not totally obscured. So looking at the partial eclipse can be dangerous because the intensity or the solar radiation is not totally obscured, right? So it is dangerous to look at the sun in partial eclipse. Talking about the total eclipse, let us say this shadow cone passes through the earth. When this shadow cone passes through the earth, then wherever the cone passes, you will witness the total eclipse. So this phenomenon of total eclipse, if you are lucky to see, you could be seeing this phenomenon probably once in your lifetime, and this is extraordinarily fantastic phenomenon of the nature. You should not miss it if you get a chance to see it. Let's say now the situation is different and now sun is on this side, and it so happens that the shadow of the umbral shadow of moon does not reach earth, right? Umbral shadow does not reach the earth. So in such a scenario, what happens is, if you see from the space, you will find that there is a shadow of moon with the light all around, and this shadow cone is not reaching the earth. So people, when they look at the eclipse from the earth, they will find that here is the sun, the bright sun, and you have the moon obscuring the sun partly. This is moon, and you will see the bright sun all around the moon, and this would be called annular eclipse. Annular eclipse may last for a few minutes, usually 3 to 5 minutes, and sometimes it could be something like 10 to 12 minutes. So annular eclipse is another dangerous kind of eclipse to see directly, because the solar radiations from all around, they can damage your eyes.